I know how.
When he would explain the lecture, and then he'd like draw a circle and then like a dash. And,
Yes.
yeah.
That's good.
It's
It's good we start our lesson with a smile.
Well, like first day of class, you were explaining how we can't miss anything, and you'd be really happy over here, and then over
Really
here, it's
sad.
really sad.
And then in the middle, you're like, hey, yeah, I'm not at school.
Well, this is obviously not going out on YouTube. Okay. So some special types of problems. And I'm trying not to block this for those of you watching this on video. We're going to find the domain for these functions. In the domain only, we're not going to find the range. And we'll use our calculators to find it graphically, but ultimately we want to be able to do it algebraically. And this gives me a chance to see how familiar, or what you know from, or what you did from Algebra 2, how much you know from that. And it's not difficult Algebra 2 stuff. And quite frankly, in the last 4 years, we have had 4 Algebra 2 teachers here. And so each year it's a different, how much did the class before learn. So this gives me some sort of okay. So the first one, number 1. We just want to find, and once you see what's going on, it's not that difficult. X minus 2. And we want, in other words, in this, we want to know what values of x can we use, or in some cases, it might be easier to figure out what values of x can we not use. Okay? So I'm going to go ahead, and you don't have to graph this. If you want to follow along on your graph for practice, that's fine. So I'm going to enter this. And you always want to remember, when you enter fractions on here, you've got to enclose the, well, some of you have the later versions of fractions where it actually comes out as a fraction. This is an old one of mine. If you got one like I got, you want to close these off with parentheses. If you're unsure whether to close this off or not, just to play it safe, close that off. In this case, you don't have to. But, so I'll put 3 and x minus 2. Do any of you have a calculator for this kind? You can make a fraction, an actual fraction. Okay, so you don't have to worry about that. But, oops. Does anybody know what the domain is of this before we even do it?
It's
2 to all real numbers, or 2 to infinity.
Okay. No.
I was.
All real numbers and all real numbers.
Almost.
Um,
Okay. Once I give you the answer, you'll go, oh, it's just, but that's okay. It's been a while. And if you want to graph, most graphs, I try to make it to where they're on zoom standard, number 6. So if you hit the zoom button, it's 6. Now, if you look at this, you get a graph, and we're really not going to deal with this technically until the end of the year. It's what's called a hyperbola. And what's happening here at this point, you got what's called an asymptote. You guys didn't cover that in algebra 2, did you?
no.
I never get that far. I never did get that far in algebra 2 either. So don't, that's not. Okay? Asymptote. And what it means is this curve gets closer and closer to this number, but it never hits it. Never. This gets closer and closer to this number, but it never hits it. Same here. Any idea on what this number is right here? 2, right. How do you know?
Because 0 can't be on the bottom.
And that's how you find out. What you do, you look at this. This cannot equal 0. All you gotta do is look at the denominator of this. And so your domain is x, I better not put equal there. X does not equal 2. And that's it. It can be anything else, but it can't be 2. Or, lots of times in your books, you don't have to write it. This is perfectly acceptable. You'll see this a lot. I don't know if you've seen this notation on sets. This means all real numbers x, so that x.
Because 2 minus 2 is 0.
What's that?
I just.
Oh, all you have to do is say x does not equal 2. Okay. So, let's do. Everybody okay? Let's go next. I gotta learn to do this from the left side. G of x equals 6x plus 7 over 2x minus 3. I better check this out. I think these things only have so much memory and it stops. We're going to. All right. So does anybody want to give me a domain for this one?
It'd be 3 over 2.
Okay, right. So x cannot equal 3 over 2 because you got 2x minus 3 does not equal 0. 2x does not equal 3, so x does not equal 3x. Now, this we could care less. This can be 0. So we ignore the numerator.
May I have your attention, please? One last call, if there's anyone in the building that has not had a picture taken, either student or staff, please come to the gym at this time. Thank you.
They always have to. Okay, x does not equal 3x. Everybody okay with that? So the moral of the story with fractions or rational expressions is you want to find the values of x for which that denominator does not equal 0. Now, let's do this one. Lisa got me on table on this too. Okay. What do you think we're going to do here to find out?
Is x does not equal 3?
Okay, there's one other one too.
Negative 3.
Negative 3. So there's 2 of them. Now, this one you could probably eyeball and know right, get it. But what I'm going to do, anybody remembers how this factors?
X. Like x plus 3, x minus 3.
Is it? It's a difference of squares. And so difference of squares, one will be minus, that's a perfect square, that's a perfect square. This is a perfect square because it's even, the exponent's even. And then, in fact, remember in geometry, I want you to know your perfect squares like 1, 4, 9, 16, and so forth. This kind of helps you on that too. And that's, so factors to this. And so you get x equal 3, or x cannot equal 3, x cannot equal negative 3. And that you should in there. Now this one you can probably eyeball and get that answer and be okay with it. But what about this one? This is one, this is kind of a watershed point. This is the one I kind of look at and see, well, what did you get in Algebra 2, or at this Algebra 1 also? See, you can't look at this right away and say,
Find the factors.
yes, I need a factor. Right. And so, you see, it works just like the last one.
Yeah, so it's 7 plus negative 2 equals We did it a weird way.
Yeah, and I said, it wasn't just last year, it wasn't just, is it Miss Hop? Was it?
Yeah.
It wasn't, I've seen it other method, some other.
We did the Chris.
We did the crisscross.
Where you have,
Like
you also
X.
write it.
Can you just teach us a good one?
Foil.
No, I like them.
No.
I.
Use
Chris
whatever
Cross
method
makes
you
sense
want.
to me.
You got it, and I'll do it my way here this time. But if you, maybe somebody did it this way.
You have to, first you have to look at the last, for the first and the last, and you're trying to get the thing in the middle, so you set up like this kind of weird crisscrossy thing, and you have to think, okay, how can I get 5 out of the factors of 14? So let's use 7 and -2. So you have -2x plus 7x equals 5x, which is the middle.
Yes.
So then you take it straight across and you have x plus 7 parentheses x plus 2.
And that's fine, nothing wrong with that, I like that. Okay? Now, hold on. Now, if you've got your own method, use whatever method works for you, because this works all the time. It's just as good as my method. Now, you want me to show you what I do? Okay. I'm not sure this is the best method, but I do a little memorizing. I've got my, so for those of you who want to use this all the time, you might just want to go, no, block the outside. I look at first sign, second sign, and actually, I think this is just as good, but I've done this for so long. And first sign, second sign, and if both my signs are plus, and this is what I mean by first sign, second sign, you always got to have plus when you factor. If your first sign is plus and your second sign is minus, one's going to be plus, one's going to be minus, and that's how I remember that, plus minus. If both of them are minus, one's going to be plus, one's going to be minus, same thing. And you got to do this. You eventually, ultimately, got to do this part anyway. And if the first one's minus, second one's plus, you're always going to have minus, minus. That's how I remember it. And then I just play with them mentally after that. But there's nothing wrong with this. So when I tell you to factor, if you don't show any work, that's fine, because to me it's all mental. But you might do this on this side, which is perfectly okay too. Okay. Anyway, we've still got to answer this problem. If you're having serious problems with this factoring, get it down, because you've got to know how to factor in this class. Not so much it's not going to ultimately destroy you, but it can hurt you. But when you get to calculus, you've got to know how to factor. When you get to college math,